Okay, are you ready? All right, let's refocus, please. Take a look at your notes for today. Okay, we are still doing limits, but what do you not have in today's notes that you had on your practice and all your notes for the last day? Huh? No graphs. That's exactly right. So let's say that you're asked to find a limit, but you don't have the graph that goes with it. Okay, you can still do limits. Here's what you're going to do. You are going to check what number your x is approaching, and you are going to plug that x in to the piece of the piecewise equation that that domain would include. Okay, so I'm going to put here to find x approaching c, you're going to plug c into where it includes your c value. Okay, let me explain to you what I mean by that. For number one, this is called a piecewise function because you have two equations that you're going to use for different sections of x. You're going to use x plus 5 anytime that your x is less than 2. And you're going to use e to the x anytime your x is bigger than 2. So if I'm doing a, what is x approaching?
0.
0. Is that less than 2 or bigger than 2? Then you would plug into the less than 2 equation, which is x plus 5. So I would do 0 plus 5, which gives me 5. Okay, next one. We want x approaching minus 10. Then I would say, okay, where does that fit in? Minus 10 is less than 2 or greater than 2? Less. So then I'd take my x approach negative 10. I'd plug into x plus 5, which is now negative 10 plus 5, which gives me what final answer? Negative 5. Very good. Okay, but do we understand why we're choosing the top for those two? Okay. Next one, x is approaching pi. We have to get a little bit more comfortable with using numbers that are letters. Okay, so pi is approximately what number? 3-ish. 3.14 is correct. Okay, where does that fit? Greater than 2. Then am I plugging into top or bottom? Okay, very good. So I'm going to put pi is approximately 3.14, which is an x greater than 2. So we're going to plug into the bottom row. Okay, and so on a test, I wouldn't expect you to write this, but since it's your notes and you might use it to help with your homework and that kind of stuff, I'm going to have you write it there. Okay, then we're going to take our pi, we're going to plug it into e to the x, so that now it's e to the pi. Okay, you probably don't know what that number is, neither do I. Okay, but we know it's a number, so it counts. Just like sign of 5 on that little warm-up that we did. Questions on that? Okay, now let's talk about what if your number is the breakpoint? Okay, now breakpoint refers to where you switch from one equation to the next. So in this example, your breakpoint is 2. Because everything to the left of 2, I'm using the linear. Everything to the right of 2, I'm using e to the x. So if you are approaching the breakpoint from the negative or left-hand side, you are going to use x less than that number's equation. If you want the right-hand side, you're going to use x greater than that number. Okay, and if you think about on a number line, that should make sense. That if I'm trying to approach 2, all of the numbers to the left of 2 would also be smaller than 2, right? And if I'm on the right side of 2, all of those numbers would be bigger than 2. Okay, so now let's come down to this next row, same example. I want x approaching 2 from the left. So am I plugging into top or bottom? Okay, very good. So I'm going to put use top row because left side means x less than 2. And then remember, the number I'm approaching is 2. but this just tells me which portion of my equation to plug into. So if it was x plus 5, now it's 2 plus 5, which gives me 7. Okay, next one. Now we want to approach 2, but from the right-hand side, what portion of your piecewise will you plug into?
Bottom.
The bottom is correct because the bottom is where all the x's bigger than 2 are, which would represent the right side of the breakpoint. So we're going to do e to the 2, which we're going to just leave as e squared. Okay. Okay, then let's go on to s. Now, what's different about s?
It's both.
Okay, x approach 2 doesn't say left side only or right side only. It's a two-sided limit. And for two-sided limits, you only get an answer if the left and the rights did what? They had to match, they had to be equal. So in this case, what would I put for this? DNE is correct. Okay, and remember, why is it DNE? Because left doesn't equal right. Okay, your sides have to match for that limit to exist. Okay. Then I want you on the first couple of these, I'm going to have you sketch the graph to go with it. Okay, your graph doesn't look perfect, but I want to connect the dots between doing it as an equation and doing it as a graph, which we've already covered. So if you will, please, you covered piecewise graphs in pre-calc. Okay, but you might have forgotten how to do it because, you know, it's been a while. So at 2, I want you to draw in just kind of like a dotted line to separate the halves of your graph. So everything on this side of the number line are the x's less than 2. And for that side, I'm going to use y equals x plus 5. Versus everything on this side of the line, I'm going to use y equals e to the x. Okay, so your piecewise graph is basically just taking little chunks of each graph and putting them on the same grid. So let's talk about x plus 5 first. Do we know what that's going to look like? Okay, y-intercept of 5. What shape is it, though? A straight line. Very good. Okay. So I want you to go to positive 5. 1, 2, 3, 4, 5. And then I want you to just draw a line that's uphill. Now, I know that my line is uphill because my x is positive, right? Versus if my x was a negative x plus 5, I know it will be a downhill line. Okay, but remember, this is just a sketch. Now we're going to come over to the other side. E to the x. From pre-calc, you should have covered e to the x is the exponential growth graph. Do you remember it starts down here really close to 0 and then it like goes like that? Do you remember that graph? Okay, so all of this part of the graph is going to get cut off, but then on this side, your graph is going to keep going up. Now, we don't know exactly what number this happens at, but we know that it is the same as whatever e squared is. Versus my left-hand side, where did it leave off at? 7. So your left side is coming into 7. Your right side is coming into whatever e squared is, which it's about 7. So does it make sense why I'm seeing this little gap here? Because my left and right limits did not come out to be the same. Okay? And then also looking at this graph, you could have probably told me, oh, the limit doesn't exist because I have a gap between my left and right sides. Make sense? Okay, go to the next one. Okay, this time I have a new piecewise equation. What is my breakpoint number? Okay, 1 is the breakpoint. Remember, breakpoint just means when you switch from the first side to the second side. Okay, so if I want 1 from the left, meaning little negative, where do I plug into? Top or bottom? Okay, if it's 1 from the left, then I want x is less than 1. So that's the top. So I'm going to take my 1, plug it into x plus 1. Now it's 1 plus 1, which gives me what? 2. Okay, next one I want is 1 from the right. Numbers on the right of 1 would be considered bigger than 1. So I'm plugging into which part of my piecewise? The bottom. So I'm gonna have 1 minus 3 squared plus 1. Okay, remember to follow PEMDAS on that. What is 1 minus 3 in parentheses? So I want -2 squared plus 1. And then remember that when you square -2, that would be -2 times -2 again. What happens to your sign? Okay, it is going to come out to be a positive 4 plus 1. And then 4 plus 1 is 5. So my left side is coming into 2. My right side is coming into a height of 5. Then what is the limit as x approaches 1? DNE is correct. Oops. Okay, DNE. Real quick sketch here. Your breakpoint is going to be 1 this time. So give yourself a little division line between both sides. For the side of x that's to the left of 1, what's my equation going to be? Y equals x plus 1. And then on the other side, I'm going to use y equals x minus 3 squared plus 1. Can y'all see the yellow, or do I need to write it in a different color? Y'all see it okay? Then from there, what shape is this? It's another line. Where's its y-axis going to be at? 1, and it's going to go uphill. So put a line that hits at 1, and it's going to go uphill, and then it's going to cut off. On the other side of the graph, I'm going to use x minus 3 squared. What shape is this side going to be? Do you remember? Parabola. And where is it going to be shifted if it has a -3 in the parentheses? Do you remember? This number moves it side to side, but it's always the opposite. So if they put a -3, I'm really going to push it this way 3. The number at the back moves it up or down. So if it's a +1, I'm going to move it up. So on your graph, you're going to go to the right. 1 puts you at the line, 2, 3, up 1. And then I want you to just sketch a U. It doesn't have to look perfect. Okay, but we know that this is a parabola. Okay, then I'm going to go ahead and draw in my open circle here. Okay, now this should clarify why my limit doesn't exist. What value is my left side coming into based on our algebra? That was the right side. Left side's off the screen, but look on your paper. What was the left side here? 2. The right side's coming into 5. So now we can kind of see why that didn't match up. Does that make sense? Okay, turn the page, do the next one with your people. Okay, really, you can probably do the next 2, but don't bother to graph it. Just do the actual algebra limits part. Okay, so 3 and 4, you can ignore the sketch the graph. Yeah. You're doing -1, would be. It's not. Did you try to cancel out the negatives? You can't. Here's why. What's -1 if you square it? That'd be 1, and then apply the negative. It's a -1 plus 2. So think about the -1. the negative crosses out when you square it. So it can't also cross out the negative that's in front of that. Does that make sense? You want me to write it down? Yeah. So you have this, right? -1 squared. And then is it +3? +2, and then there's a negative here, right? What is, remember PEMDAS, I have to do the exponent first. What's -1 squared? What, right? And the negative in here gets crossed out when I square it. So now it's 1 with a negative in front, +2. You can't cross these out with each other because this one is gonna get crossed out all on its own when you square it. Does that make sense? So it'd be 1.
That's a lot of one.
Yeah, it is a lot of ones, you're right. Absolute value, don't be positive and you're negative zero. So absolute value will just be 4 and then change. No, we don't. Correct. Yeah.
Wow.
But now, so that's only gonna be one side, right? Remember, if it's the break point where you switch from one to the other, remember you have to check both pieces. And they have to match. So what's your break point?
Oh, no, you're.
Right, that's where I switch from x squared +2. Right, so the only way you can find a break point limit is if you plug into both sides one time. So like for this one, when I was trying to check it at 2. Because that's where I can wait for one step. Okay, that's fair. So let's go back to this one. You want to find.
I thought it was like the other one.
Then you need to find to the left side, so it's like the right side.
This one. Same number.
So when I do the left side, I plug in.
This is -1.
Yes. Okay, label that with like this.
What was the?
Okay, but remember, this is a two-sided movement, and now I need to do the right side, which would cover all this.
Zero.
Now it goes to my bottom piece, and make sure that it matches what I would have got.
Yeah.
And then what is it?
If I had also.
Nope. And then.
Okay.
Go to your side.
-5. It's less.
Now, why did we not have to do that word?
So. Absolute value.
They weren't where you switch one to the other. Does that make sense? So that one switched at 2. So when I checked 2, both of these had to match. Does that make sense? Thank you.
Next one. Where's the
Yes. Did you have a quick question? It is 2. Yes. Will you take the gold powder and you know that? 5 minus 2 is 3, and then if you absolute value the number, that's not right. Yes, but okay, so if this is the break, which it is, we're going to put from one side to the other. We don't plug in where this guy's the break. Remember,
Oh, you.
Okay, real quick, I'm seeing some part C's that are incorrect. So let's make sure that we understand how to do part C. So for this one, for A, I also saw some people get it wrong, but I tried to catch you. What was the correct answer for A? Okay, 1 is correct. Okay, let's go over why. Listen up. Okay, the reason that 1 is correct is that when you plug in -1 to the less than 0 side, you have this. But remember PEMDAS, you have to do the exponent first. I can't cross these negatives out with each other. What is -1 when I square it? That goes to +1. And then I apply the negative in front of that. Okay, so the reason you can't cross these out with each other is because this negative crosses out when you square it. And then it's gone, that this negative in the front stays, and -1 + 2 is 1. Okay, for your second answer, you should have gotten E squared. Everybody good there? Oh, wait, am I wrong?
I think
E squared plus, oh, I see what you're saying now. You're right, my bad. Okay, E squared plus 1 is correct. Okay, now go to C. If you only plugged in to the top because you said equals 0, that's wrong. Remember, for limits, you have to check the left and the right side. So if you didn't put this notation, I want you to add it to your work. For X approach 0, this is the break point. So you have to check left and right. Left and right. So where will I check the left side? I'll plug into the top. Where will I find the right side? I'll plug into the bottom. Let's do left first. Limit X approach 0 from the left. Okay, that should be on your paper, but probably you didn't put it, but it's fine. Okay, just add it there now. So I'm going to check the left limit first. Then I'm going to check the right side limit second. Okay, let's do left first. I'm plugging in 0 here. What is 0 squared?
0.
Turn it negative, it's still
0.
add 2.
2.
Gonna be 2. So it's -0 squared plus 2 gives us 2. Okay, now let's do my right hand limit. I'm plugging in 0 here. E to the 0 plus 1. But what is anything to the 0 power?
1.
Not 0, it's 1. And if this is 1 and I add another 1 to it, what is the right side limit going to equal? 2. So did my left and right sides come out to be the same number?
Yes.
Then this is 2. But what if they had come out to be different? Then you would put DNE. Now, quick question. Why did I have to check both pieces for C, but I didn't have to do that for A or B? Because it's the break point number, which was 0. Okay? So now I want you to look ahead at your part C here and make sure that you did that. Okay, if it's the break point, okay, meaning you switch from one piece to the other, you have to check left and right side. And if you'll also make sure your limit notation is there for that part, okay, that would be great. Here's what I'm looking for. Okay, for part C, you would need to find the limit as X approaches 3 from the left. And then the limit as X approaches 3 from the right. Okay, then once you find those two, you look and see if they match or not. Okay? Also, the bars, the absolute value, y'all know that just turns whatever's inside them positive. So for this one, if it was absolute value -5 minus 2, that would go to 5 minus 2, which is 3 for your first answer. And then 4 plus 1 would be 5. Okay, but remember, I don't have to check both sides for -5 or 4 because they're not the breakpoint, 3 is. Okay, so for my left limit, what am I gonna get? Can someone tell me the answer?
1.
Okay, 3 minus 2 gives me 1. And then my right side, what's my answer? 3 plus 1 gives me 4. So my left side is 1, my right side is 4. What's my overall limit? Yeah, very good. Go ahead. Question? Okay. All right, we are going to skip example 5. And then we're gonna go to the next example, which is also 5, because I numbered it wrong. So skip this one and go to the next one. Can I pull this page off? Are we all good? Okay. Bottom one, I want you to look at the way your piecewise function is written. Okay, does it say x less than 3 and x greater than 3? Okay, no, this is another type of piecewise. Here's how this one works. Okay, when x is 3, I'm going to pick a y value of 5. And anywhere that x is not 3, I'm going to use x plus 1 as my formula. So I'm going to have you graph this first, and then we're going to go over the answers for down here. So sketch a little graph for me here. I want you to go out to 1, 2, 3. And then I want you to draw in your little dotted line just like we did on the front. Okay, when I am at x equals 3, what y value am I going to pick? 5. So I want you to go to 3 and put a dot at, we'll say 1, 2, 3, 4, 5, right here. So when x is 3, I'm going to pick 5 as my y value. Okay, but then everywhere that x is not 3, I'm going to use x plus 1, which is a straight line. Okay, now question. On the left side, are those numbers equal to 3 or not 3? They're not 3. What about on this side? They're not 3, right? They're bigger than 3. So on the left side, I'm not equal to 3. And on the right side, I'm not equal to 3. Then this piece is going to make up all the rest of the graphs. All the rest of the graphs. And it is going to be including both the left and right side of that dot. Okay, not equal to 3 is going to include all the numbers less than 3 and all the numbers bigger than 3, which means it's going to make up the whole rest of the graph. So put your dot at +1 for your y-intercept. And then I just want you to draw an uphill diagonal line. Okay, we're being kind of lazy with our graphs here, but it's fine. Skip that one spot and then keep going. So for the entire graph, I'm using x plus 1, except for at that one spot. Okay, so now let's do our limits algebraically. If I want x approaching -2, is that an x value that is equal to 3? Or is it a number that is not equal to 3? Not. Then where am I going to plug -2 in? Top or bottom? Bottom. What is -2 plus 1? Okay, that would give me -1. Okay. Let's go to the next one. Now I want x approaching 2. Is that a number that equals 3 or is not equal to 3? Okay, 2 is not equal to 3. Then where do I plug in? Top or bottom? Bottom, which means that 2 plus 1 is 3 for my answer. Okay, last one. I want x approaching 3. Now this is tricky. X approaching 3 is 3, right? So you would think, oh, I'm going to pick 5. Okay, wrong. Remember that limits, you're just getting close to that spot. You don't care what kind of dot is there. So as I trace in from the left and the right, I'm going to be on the line. So I never am going to really pick 5. So as I come in from the left side, my numbers are less than 3. Then are they really 3? No. And as I come in from the right side, those are all the x's bigger than 3. They're not 3 either. So I'm still gonna plug in my 3 to the x plus 1 piece. And 3 plus 1 is 4. Uh-huh, let me explain it one more time. So remember, your breakdown is for 3 or not 3. If I want to trace from the left side of the line, I would cover up the graph. Everything over here is gone, right? As I get closer and closer, are my x's 3 or not 3? They're not 3 because they're less than 3, right? I don't care what happens here. I care about as I'm tracing in, what am I getting closer to? Then I'm going to cover the other side. Now this side is gone. As I trace in closer and closer, are my numbers equal to 3 or not equal to 3 as I get closer? They're not 3. Now, when I get to 3, I don't even care what happens because I'm only tracing towards it. I'm not actually getting there. Does that make sense? So if you get this type of equation where it's 3 and not 3, the only time you would use the 5 is if it asks you what is f of 3. And then you would say, oh, my closed dot is 5. But your limit at that point is going to be 4. Does that make sense? Okay, so when you're ready, turn the page. You have a couple more examples. We're going to not do the sketch. So just do those top 4. You have an F and a G. One of them is an equal to, not equal to. The other is a less than and a greater than. Okay, so give those a shot. Yep. This one's not. If x is approaching 1, remember, you don't care what happens at 1. You care about as you're getting closer to 1. So as yes, go ahead, take the pass. So as you're getting closer and closer to 1, are those numbers going to be 1 or not? Not 1, because remember, you don't care about at 1, you care about next to 1. So you're going to still plug in to the x not equal to 1 piece. So basically that piece is your left and right side because it's the whole rest of the number line and you ignore dots when you're looking at limits. Plug in 1 to your not equal to 1 section. Good. Those are both right. That is right. You have to check both sides, right? Oh, can you put the limit stuff? Since the break point? Like all the, only on part D, yeah, where you do like the limit from the left. Yes, right. What about x is approaching 1 and 1 is right? You're gonna have to show the left and the right. Okay, some of you guys are gonna get big points off when we test over this because you're not putting your limit stuff. So for D, you shouldn't just have numbers. You should have the limit as x approach 1 from the left. And then the limit as x approaches 1 from the right. And then once you have those two values, then you can say it's D and E. But if you just have like numbers without any labeling on what limits they are, that's gonna hurt your grade for your test, okay? So when we're doing your notes, will you just add that to it, please? What was the left side limit for D? 5 is correct. What about the right side? 10 is correct. 2. Okay, I was like, is it correct? Okay, and then those are different. So then what's my final answer? D and E. And remember what we put in the notes last time was D and E because and then you show the left and the right sides. Your test is gonna say, if a limit doesn't exist, explain why. And that's what this piece is that I just want you to practice, okay? So if you will, please pull out your computer. Do you want these other answers? This one was 9, this one was 6, and this one was 10. Right? Okay. Pull out your computers, and we're gonna do the first delta math. Maybe we won't even do it together. But you have a blank paper on the back of your notes if you need some scratch work space.
What is that? It's like one where like Jesus gave, I've been trying to catch the seasoning beaches like that. I don't know.
Okay, while you're getting logged in, my question is up here. Here's the question. All of your questions are the same for the first one. Am I plugging in? Just look at mine. To the left, the right, or both? Okay, -2 is the break point, but what type of limit is it? Only a right side, then when I plug into the top or the bottom. Okay, on the notes, I always made it less than on top and greater than on bottom, but where is the greater than for this example? Greater than's the top, so just be careful. Delta math didn't always put it in the same order. So if I want -2 from the right, then I'm only plugging in to the x greater than -2 side, which is 1 plus x squared. So then I would have 1 plus x squared, which is -2. -2 squared gives me what? 4, and 1 plus 4 gives me 5. Okay, but notice, even though it's the break point, I'm not plugging into both sides because this is only a one-sided limit to begin with. If it asks you for x approach -2 period, then you plug into both sides, make sure that you get the idea? Okay, I do not care if you keep track of the notation for left and right limits when you're doing delta math. Mainly for your notes, if you're looking back on it, I want to be right. Okay? You can do it. Ask me if you need help. Yes? Yes. Oh, wait, actually, will you wait till Sasha gets back? She has the mouse.
This one you just bottom.
Is it a plus? Yeah, you do bottom. The last door. Okay, good to see you. Have a good weekend.
That's how.
Did you